So today we are going to be doing 4-5, which is going to be solving quadratics via factoring and square root method. So a lot of the methods we're going to be using to factor today are ones we've already learned, and we're just going to be adding in one extra step. So factoring is basically the procedure of rewriting an expression or equation as the product of its factors. So basically in a way that if you were to multiply the factors together, you would end up back with the standard form. The zero product property states that for real numbers or real expressions, expressions that represent real numbers, if you have two values that you can multiply together, and you multiply them together and the result is 0, it must be true that one of those values must have at least been 0 for that to happen, right? If you multiply two numbers together and your answer comes out to be 0. So for that reason, this is what allows us to actually set these pieces of the equation equal to 0, because if the whole thing's equal to 0, then it's true that one piece must have been 0 for that to happen. So in plain language, like it says, you set each factor equal to 0, and then that allows you to solve from there, okay? So a few strategies for solving quadratics. We are going to learn more as time goes on, but GCF, most important because the GCF is kind of the framework for everything else. You have to factor out a GCF to get anywhere else with any other method, okay? Grouping means you're going to group factors into ways that we can factor them, and we've talked about grouping in the past. We're not going to talk about it too much today. Difference of squares, and then square root property. That's basically where you take the square root of both sides. So let's go ahead and try some of them. So we're going to start with the simple GCF. So typically the only time you're going to get them on opposite sides is if you're using square root method. But here I'm going to add the 9x to both sides so I can get a better understanding of what to do here. So I'm going to add 9x to both sides. Sorry, my tablet's turned off. It's just rebooting. There we go. Okay. So 9x added to both sides. And that leaves me with 6x squared plus 9x is equal to 0. Now that I have this, I'm going to look for a GCF. Any ideas?
3.
3, and also we can take out an?
X.
Good. So we take out a 3x, which leaves us with 2x plus 3. And that whole entire thing is equal to 0. So this is where we would have left off last week when we learned about factoring, but now we're going to take it, bless you, to the next step. So you're going to set each of these products equal to 0. So you're going to set 3x equal to 0, and you're also going to set 2x plus 3 equal to 0. So how would I solve the first equation?
Just put a 0.
Yeah, well, you would divide both sides by 3, which comes out to be x equals what?
0.
And then for this one?
Subtract a 3 and move it to the other side.
Good. Subtract 3 and then divide by
2.
2. So I get x equals negative 3 over 2. So when you're looking for solutions, these are also known as x-intercepts, as we learned about the other day. So x-intercepts only ever occur when your y value is 0. So whenever you're finding these solutions, if they're in the form of an ordered pair, the y will always be 0. Now the x are the two x's that we just found, which are going to be 0 and negative 3 over 2. So does anyone have any questions about that one so far?
Yeah, can we hold it for a second?
Yeah. So my two solutions are 0 and positive 3. So that means that if I were to graph this quadratic on Desmos, these are the two spots that we would hit the x-axis, okay? Does anyone have any questions about that?
Instead of like, I mean, we obviously meant using
No, so I ask you specifically for intermediate steps because I need to make sure that you know how to do the work. Nothing is going to be like that long of a problem. Like I don't think this one's like too long. I'm not going to give you one that's like 100 steps or anything. But yeah, Desmos, that's what kind of what I was saying to my last class. It's a good way to check your work though. All right. So moving on. Now we're going to talk about using the AC method at times, or sometimes we just factor out a GCF. So whenever you have a trinomial like this, you need to add over, so you have everything on one side of the equation. And then when you add over the 20x, you need to make sure that it is in standard form. So it's going to be 4x squared plus 20x minus 56 is equal to 0. So does everyone understand why I repositioned it and how I did? It's got to be x squared, x, and then the number. Now before you use any AC method, you want to make sure that we have factored out any possible GCFs. Good.
Factor out 4.
Good, good. We're going to factor out a 4. So now that we've taken out any possible GCFs, we are now going to factor into two binomials. So do you remember doing this last week? Factors of negative 14 that add up to positive 5.
Oh, yeah.
Any ideas? Good, 7 and negative 2. So once you have what's called the fully factored form, that's fully factored form, triple F, you basically then want to set each of these equal to 0. So we have 4 is equal to 0, we have x plus 7 is equal to 0, and we have x minus 2 is equal to 0. So you set every product equal to 0. Now, what do we notice about this first equation right here, 4 equals 0? It's untrue, so this is what we call it gets rejected. The first one, if it's just a number equals a number and it's untrue, you just say it's rejected, okay? It's actually called extraneous. Now, what would this equation solve to be? X equals, and this one would be x equals, good. So these are going to be negative 7 and positive 2. So what you're going to start learning as we do more graphing and whatnot, if you have a number on the outside, that just stretches your graph more. But the zeros stay in the same spot. It's like you're here and here, and then it just gets stretched out. Okay? So we'll talk about how that affects the graph, but it doesn't affect the solutions of the graph. So oftentimes when you have a negative value in the front of your x squared, the easiest way to deal with this is to actually factor out a negative 1. Do you remember doing this last week? So when you factor out a negative 1, it's just going to change the sign of every term. And once that happens, you're then going to factor this into two binomials. So factors of negative 32 that add up to negative 14.
16 and 2.
Good. Negative 16 and negative 2. Now we're going to set each of these equal to 0.
Miss Russell,
Yeah,
wouldn't it be a positive 2?
you're right. It is a positive
Yeah.
2. Thank you. I was like, I think it looks different than earlier, but we're just... So what happens to the first equation?
It's rejected.
Good. What's the answer to this one?
Positive 16.
Good. And this one?
Negative 2.
Good. And it doesn't matter which order you put your solutions in. unless the question says something like put positive 1 first or put the negative 1 first or anything like that. Otherwise, unless specified, you can write it in either order. Okay? How's everyone feel so far about these? Not too bad, right? Alright, now we're going to try number 5. So once again, we need to get it into standard form. So not only am I going to add the 12 over, I'm also going to rearrange it so that my x squared term is first, then my 11x, and then my positive 12. So that it's x squared, x, and then the 12. So is everyone good with the rearranging process here? Now we're going to look for a GCF. And do you see if we have one here, yes or no?
No.
No, because they're not all divisible by the same number.
11 is a prime number, right?
It is a prime number. And the only way it would work is if there was all these other numbers had a factor of 11, which they don't. So this is when we go ahead and we use the AC method, which is where you multiply the A and the C together, which gives us just x squared plus 11x plus 24, which is equal to 0. And then in this intermediate step, you factor as normal. So we're looking for factors of 24 that add up to 12. I'm sorry, 11, not 12. Factors of 24 that add up to 11?
8 and 3.
Good, 8 and 3. And then we're going to divide by the A term that we originally multiplied by, which is 2. If it divides, you divide it. If it doesn't, you bring it back over in front of the x. And then what's my next step? Mm-hmm.
So you want
Good. Set them each equal to 0. Now, if you feel comfortable enough with your mathematical abilities, and you're doing it well, you can mentally solve these equations. That's fine. So this one comes out to be x equals
-4.
Good. This one's a little more tricky because it's a two-step, but does anyone know what it would be?
X equals -3/2.
Good. X equals -3/2.
So why don't we just leave it at that other, like in the other form?
Good question. So you're saying just set this equal to 0?
Yeah.
Now, if your only purpose for this problem was to get the solutions, yes, you can totally do that. I just want to let you know that if they ask for proper factored form, they will expect you to bring that number over. So I just don't want to get anyone in any bad habits of leaving it. Like when I know I'm solving, I do that. But just be aware that proper factored form has to bring it back over. But if you're comfortable with that, you can just do that as well. Good point. All right. So let's go ahead and try number 6. So do we have a GCF here?
4.
Good. So what are some factors of 9 that add up to -6?
-3, -3.
Good. -3 and -3. So you can probably start just looking and knowing the solutions at this point, right? So this comes out to be x equals 3 and x equals 3. Now, I had a really important question from someone earlier that said, well, if the zeros are the same, do I need to write it twice? And up to Algebra 1, you probably didn't really know the difference between having one answer that's the same or two. But in this class, we're going to go into something called multiplicity. So the amount of times a certain zero occurs actually does affect the graph. So yes, you do need to write it twice, even if it only, if it's the same one. because what that means is the graph hit that value only once, but the amount of times that it hits that value actually affects how it hits the graph. So that's kind of for a future lesson. But something that I want to show everybody real quick before we move on, I want to show you what the number on the outside does to the graph. Yeah. So as you can see here, I have one with the 4 on the outside and one without the 4 on the outside. As you can see, the one with the 4 on the outside goes up much faster, but what the 4 does not do, it doesn't affect the zeros of the graph. See how the 0 on both of them is still 3, 0? So I just want to kind of show you how that works, because that's why the 4 isn't even included in the solution at all. Alright, so now we're going to move on to our next set, which is going to be solving quadratics that are in the format of difference of squares. So we talked about difference of squares in the past, but I will kind of refresh your memory here. Difference of squares means difference means subtraction. Okay, that's where the word difference comes from. And it means perfect squares. So when you see that you have subtraction of two perfect squares, as you can see 25x squared and 49, I meant to say 25, are both perfect squares, right? So when you see this, you're going to write two parentheses. One of them is going to have a plus sign and one of them is going to have a minus sign. Now, we dug a little deeper into why this works in the previous lesson, so if you want to look back at, I believe it was 4.2, we talk about why. But what is the square root of 25x squared?
5x.
Good. And what is the square root of 49?
7.
Just 7. So we then set these equal to 0. And then we just solve them. So as always, our y is 0. And if we solve these, what do we get for the first one here? Yeah, you might have had it backwards. So one of them's positive 7 over 5, and one is negative 7 over 5, based on how, what order you did them in. But if you solve those equations. I do skip over solving 1- and 2-step equations in this class because it is Algebra 2. But like I said, if you feel comfortable with or uncomfortable skipping it, you can totally just do the math out. Or you just want to practice, or whatever reason you like to do it. Alright. So we look here, do we have the difference of two squares? Yes, so we have a positive and a negative. What is the square root of 16x squared?
4x.
Good. And this one is going to be 9. We set those equal to 0. The y value is always 0. And what are my two solutions? Good. So does everyone feel okay with how we got those answers? Does anyone need clarification on anything? Alright. So now we're going to talk about ones that require the square root property. Okay? Now, this one is a cubic function that ends up factoring into a quadratic part. To do this, we're going to have to find a GCF here. Does anyone know what the GCF is here?
X.
Good. We're going to take out an x, which leaves us with x squared minus 5. As always, I'm going to set my two parts equal to 0. Now this one is pretty obvious. It's just 0, 0, right? We dealt with that. We're good to go. Now the other one, we would add 5 to both sides to solve. We would be left with x squared is equal to 5. And then what would we do to get rid of a second power? Square root. So whenever you want to reverse a square, you use the square root, okay? So, when you square root one side, you have to square root the other. And anytime you square root to find an answer, you always have to put in a plus or minus. And the reason that you have to do that, thank you, is because when you have something squared, that number can be positive or negative, right? Negative 3 squared is positive 9. Regular 3 squared is also 9. So for that reason, you have to have the positive and the negative version of the solution. Negative radical 5 and regular radical 5, okay? Now, we don't simplify radical 5 because the only thing it will give us is a decimal, and we don't want that. So we just leave it as square root of 5. So, does anyone have any questions about that? All right. So let's try number 10. What is the GCF here? We're going to set our parts equal to 0. What happens to the first equation?
Becomes extraneous.
Good, extraneous. That's how you spell it. So here we're going to add 6 to both sides. We're going to square root, which gives us x equals plus or minus the square root of 6. So our two answers are radical 6, 0, and negative, remember keep the negative on the outside of the square root, 6, 0. So the square root of 6 breaks down into 3 and 2. I don't know if you remember back to when we simplified square roots, it's been a while, but that doesn't actually simplify to anything. So you just leave it as is. Nothing to worry about there. Anybody have any questions before we move on to the last view? All right. So the next thing we're going to start talking about is how we would write an equation from scratch, okay? So on the first one, we're basically working backwards here. Usually we're finding the roots. Now we're going to work with the roots to find the equation instead. So it says state the simplest quadratic function that can be formed with the roots x equals negative 1/4 and x equals negative 2. So we kind of learned from the previous problems that when we have a simple root, like this one here, if we have a root of 3, it came from x minus 3, right? So it changed signs. So now if we want to work backwards and get back into factored form, what do you think is going to happen to the signs? They're going to switch. So this would mean that they came from x plus 1/4 and x plus 2. Now there is one little issue with this. When you're in proper factored form, you can't have a fraction. So what can I do with this denominator? Bring it out front in front of the x. Good. So this is what we call its proper factored form. So it says state the function, so we're going to use f of x is equal to x, oops, I meant to say 4x plus 1 and x plus 2. So does everyone understand how we got that? Now we could go backwards to check our work. You can set each of these equal to 0 and make sure that it gives you those two answers. That's a way to kind of check your work. Now from here we need to go into standard form. So to go to standard form, we're going to have to multiply these binomials together. So I'm just curious, FOIL or area model? What did you learn?
Foil.
Anybody in here use the boxes?
I did learn that, now I know what is that, so I don't really know how to do it. So my mom taught me foil.
Alright, we're going to do FOIL for this one, and then I'll do the area model for anybody in the next one who was preferable to that method. So FOIL is an acronym. It just tells us what to multiply together. So how to do FOIL is you're going to do first times first. Okay, that's the F, which is 4x squared. So that's where the F part of FOIL. Then we're going to do outer times outer, which is the 4x and the 2, which is 8x. And then we're going to do inner times inner, which is the 1 times the x, which is just x. Thank you. And then we're going to do last times last, which is going to be 1 times 2, which is just 2, which is where the L comes from in FOIL. Yes? Yeah. Wait, actually, can you wait for her to come back, please? Thank you. So now we're going to combine these two right here, okay? Because they are like terms. So our final answer is going to be f of x is equal to 4x squared plus 9x plus 2. So was everybody able to follow the FOIL method in case you didn't remember or hadn't learned it in a while? What we did there? Alright. Am I good to move on to number 12? Alright. Number 12. So it says, state the simplest quadratic that can be formed with these two x-intercepts. So it's the same idea. These are your x's. So it's going to be x minus 3.
Plus 3.
It changes sign. We're going backwards. We're trying to go back to factored form. So if I set this equal to 0, it would give me a positive 3. Now what do I need to do with that denominator?
Put it in front.
Put it in the front. So this is my factored form. Is everyone good with how to get factored form? I'll get it. Alright, so from here, we're now going to multiply these together. So if you want to use area model, you can do that too, or FOIL. So I'm just going to quickly show you how area model works. It's a 4x4 box. And then you basically just put x minus 3 here, and the 5x minus 4 here, and you multiply the corners of the box. So that's going to be 5x squared minus 4x minus 15x plus 12. Now these are like terms, so they will combine. So my final answer for standard form is f of x is equal to 5x squared minus 19x plus 12. So I just want to kind of like help you make the connection here between these two things. So basically, say you were given this and they wanted you to find the zeros. You would look, if we had a GCF, since we didn't, you would use the AC method, you would factor it, and you would end up with this format. Then to get the zeros, you would then set each of these equal to 0, and you would get those answers. So now we just worked backwards through the process. Does everybody see that, how that works? Alright, so now we're going to do a few that have one extra component in them. So Now we're going to talk about when we have a stretch factor. So I want to talk a little bit about how the a value affects the graph before we start this. So on this tab here, I have the quadratic parent function in blue, okay? Now notice if I change the value in front of the x squared, it compresses the graph. It makes it squished, okay, right? So that's what we call a vertical compression. Now if we're in standard form, a, b, and c, what value did I change? A, b, or c?
A.
A. So the a affects the graph in this way. It can either vertically stretch it, it can vertically compress it if the value is small, like 0.5. See how it gets smaller? The graph gets wider. Or it can also reflect your graph over the x-axis, and it does that when that value is negative, okay? So that's how you know what they're asking you to do. So it says state the simplest quadratic function that can be formed through a stretch factor of 2 whose solution set is. So I want you to understand what a solution set is. A solution set tells you separate values for x, okay? It is not an ordered pair. So this is just telling you there are 2 values for x that we have. Okay, it's just another way of saying that information. The stretch factor is your a. So how you set up factored form is similar to before, but the only difference is you put a 2 on the outside here. So times x minus 6, remember you have to flip the sign, and then times x minus 1/8. So remember how earlier I showed you how we had these zeros, but we had a number on the outside that didn't change the zeros? That's what's happening here. We have to bring it back in because it does affect the graph in a different way. So to complete the factored form, we just bring the 8 over. So that would be the fully factored form. F of x, because they want a function, is equal to 2 times x plus 6 times 8x minus 1. Now, to get it into standard form, we're going to multiply these 2 together and then distribute the 2. So that's going to be 2 times 8x squared minus x plus 48x minus 6. These are like terms. And what do those 2 like terms combine to give me?
47.
Good. So I'm just going to rewrite it as 47x. So what would be the last step to get it into fully standard form? If I have to multiply everything together, what would I do with this 2? We want to multiply everything together, so I have to
Yeah.
distribute.
Oh,
So that's 16x plus 94x minus 12. So that would be like a question I'd give you in the beginning. You would factor it and get this factored form, and you would get those zeros. So does that process make sense? Okay. So the last one we are going to do now we're going to talk about a reflection across the x-axis. So a reflection means that your a value has to be -1 or some negative number. So if it said a reflection and a vertical stretch of 2, you do -2, okay? So reflection just means it's negative, and then whatever other application they asked about. But they don't have anything else here. They're telling us our x is -6 and 2. So that means our factored form is -1 times x plus 6 times x minus 2. You'll often see them, instead of writing a negative 1, they'll just put a negative sign on the outside of the parentheses like that. Now to get standard form, we are going to multiply these two together and then distribute the negative 1 as the last step. X squared, that's going to be negative 2x, 6x, and negative 12. These will combine to give me what value?
4x.
Good. And then what's the last step to get standard form?
Multiply by negative.
Good, I have to distribute that negative 1. And that's what I get. So if you want to test out this method, you can work backwards from standard form by factoring out the negative 1, factoring into two binomials, and getting the zeros. So your homework tonight is to do the 4-5
Yeah.
assignment due tomorrow at 11:59 p.m.